Hello everyone. You know the video is going to be good when the sound is scuffed. It's because I don't have an actual microphone. It's my own, only the laptop microphone and the webcam is picking up stuff. So yeah, I think this will be the 0th or like the very first episode of like a series where I talk about, I think, programming in general and like computer science stuff. And yeah, I don't really know what I should say. It's kind of hard speaking in like full English. I am Hungarian, first of all, but I wanna go over what I wanna do in this like series if anything happens to it. I don't think I'll upload this until I at least make like more episodes, but this will be just like an uncut introduction. So yeah, my name is Steve. I have never really studied programming. Maybe in like high school we had like information theory classes or like informatica, I don't know how you say it. But you know that I'm a true larper because I use Linux Mint and I and I code in the terminal. You can already see the NeoFetch is already up and running. And I also have some epic shortcuts so that I can zoom in and out. So I'm a professional LARPer now, and of course, as any good LARPer, I only use the terminal stuff. I have a directory for this chess project, and I basically only have one main.c file, and I can't really name this thing like a chess engine yet because I don't think I said this, but I want to make a chess engine. So I want to make a program that you can play chess against. So that would mean the program is like a capable like opponent for you. So the game can be played. The computer is like a capable adversary against you. And I don't really know what else a chess engine needs. Yeah, maybe stuff like showing which position is better or for versus and stuff like that. But I can't really say it's like a chess engine yet because right now it only displays a board. So it's not even like a chess game. It's just like a chess. It's just like a program which displays the HUD or like the board. So this is So basically this is just like a chess display application. So basically everything is just like printed to the terminal. I've tried using like very like tutorial based like OpenGL and stuff and like SDL. The most I could do with SDL was like I couldn't do anything with OpenGL. I didn't have time to learn it. I think the coolest thing I ever did with SDL was like a triangle rasterizer and then making like more triangles, making like a cube and then rotating it. So that was my like basic achievement. But now I want to create a chess engine. So that would mean you start the game. Here's the board. I think I could zoom in once more. Okay, you can see the board. And enter a move. Okay. Let's say I want to move the e2 pawn to e4, and basically that's what happens. This is the only thing that I could come up with on my own. Not on my own. I've read a bit of not literature, but do you say like documentation of like chess engine structures. I watched lots of videos, and I didn't really try to follow them like. Sebastian League made 2 great videos, I think 2 or 3, I don't know, like 3 great videos on like a chess engine. I watched them over and over again. There was another great video about a person who was talking about writing their own chess engine, and they kind of resonated with me because it's I like to play it, not as often as I would like, but it's a very interesting game. And it's so cool that your computer can play against you. I think like it's really cool. So yeah, we just ran the program, and it asked us to make a move. Okay, and it displayed the board again. I don't know how in depth I would like to be in these videos, but I don't know if anybody would even watch this, but I will just say what I want to say, and yeah. Oh, and I hope everybody likes my Minecraft font terminal. I think it's cute. But yeah, basically, the main idea behind this chessboard, or this chess like program, like most other chess engines, is that every piece has a 64-bit number associated with them. So when I think I can draw this in like Obsidian, because of course I use Obsidian, and I also prepared some questions for me if I ever forget anything, but I will come back to these later, I think, and I just need to connect my tablet. Okay. Why doesn't it work? What the frick? Okay, it works now, okay. Oh yeah, and I just want to show my little like board. This is where I kind of try to figure out stuff on my own, like how does our program loop and stuff, or like what does it mean when a movie is legal and stuff. So this is where I just like sketch out everything that I'm thinking about. Did I? Yeah, I wrote it in English. Okay. Okay, so basically the main idea behind this chess program is, oh yeah, we have a picture right here. Let's say that this is our board right now. We need a way to keep track of the pieces that we have. So, and I think this is basically the explanation that video made, that I was talking about. But one idea would be like to have like a board, like array, and we could have like rows, like this is like the kind of first row or like second, and we could have like the, I don't know, fifth or like sixth row, I don't know, yeah. And we could say maybe like if the, I don't know, or like rows and columns, I don't know, so like the first, this would be the second, so the second row and the sixth column, I think this would be it. So like here would be like a pawn or something like that. Okay, so you would write something like white pawn. You could do something like this, and you could like make for loops and search through the board arrays and try to do logic like that. But a better idea is to take every kind of piece that we have, and I also made a separate number for the empty tiles, like right here, and try to encode those pieces into like a bitmap or like a bitboard. And the main idea that the chess engine uses is that we have 8 rows and 8 columns, so we basically have 64 tiles in a chessboard, which means that we could, for example, let's say that we just want to write down the black pawns. We can draw all of the board positions like this, and where a black pawn is sitting, there would be like a 1. So there would be like a 1, there will be a 1, here a 1, here a 1, and basically we are just encoding the board position piece by piece. So this would be the number for the black pawns. For, I don't know, for like the black rooks, it would look something like this, like 1, something like this, because the top 2 corners are the places where black rooks are sitting right now. And when we want to draw the board, we basically just overlay these. So I'm just gonna quickly show the code. It's going to be awful, and of course I use NeoVim because I'm a true larper. So here we have the pieces encoded in like a list. The 0th pieces is like the white pawns, and I don't even remember where it is in the code, but where did I write this? So I can't even remember it, but basically we are trying to overlay the the bit boards with the pieces. So we have like an empty board, I don't know, like this, and let's say we want to fill it with pieces. let's just put like a 4x4 one here. Sorry for the coughing. So if you want to overlay the the bitmap to the board, we would see that okay, we have a pawn right here, we can draw it, we have another pawn here, we have another pawn here, we have another pawn here. Okay, we have the pawns. Let's see the black rooks. So now we have one here, and that's basically it. And then we would have like another number for like black bishops. That would be like a black bishop, and so on. And if you overlay all of these numbers on top of each other, then we would get our board back. And just so that it's clear, this is basically how the board is looking. So we have like the number for the black pawns, and this is basically just a 64-bit integer, like an unsigned integer. And if we decode this, it would be something like I can't really decode it in head, but this would be like a really large number. And in the chess program, if I quit, this is basically what we are seeing right here, because we have the white pawns bitboard. I think we could call it like a bitboard. If we try to put these rows next to each other and only put a 1 where a white pawn is, we would get back this huge number, this 64-bit number, and after that the white rooks and so on. And I also made a bitboard for empty tiles. Okay, so basically that's how the display works. We overlay all of these numbers. We overlay all of these numbers, and and that's how we display the board. And I think I don't even do that, because if I remember correctly, I just have a fan string here, and I think this is what the program decodes. Let's just change this to like I don't know, like a K, and let's see if I compile it, if I can find. Okay, if I compile it, 99, see, program. Yeah, okay, so that's how I do it. So I basically don't even use the bitboards right now. The next challenge for me would be to take these bitmaps, and actually what I try to explain, to overlay these on top of each other and try to draw the board this way. So basically right now the board, like here, doesn't even correspond to the bitboards right here, so it's still like a work in progress. But that's basically how the display works right now. And after that, we have a move, the program asks us to make a move. So if I write down E2 and E4, it's trying to decode what's sitting right here. And I wrote a small like function that I call this a from index, and it can decode that the E2, like this is where we are moving from, this is sitting on this piece right here, which if we try to like collapse it back together, this would be the, I think, yeah, this would be the A, B, C, D, E, yeah, the E2 pawn, and the 2 index would be E4, and that should be right here. And if we see, it's like the 4th row, if we go from here, and the 4th piece. So yeah, this line right here just decodes the move that you make. It's so hard to explain everything, or like this stuff. I really should write a script or something, but yeah, it basically decodes where you are, which piece you are moving from to which piece you want to move to. So, and yeah, and it also shows the piece index. So the piece index for this would be the white pawns. Yeah, this. So we would like to move a white pawn, and we would like to move it to a place corresponding to the 12th piece bitboard, which would be this one, the empty tiles. And I just want to preface, I didn't use any AI during any of these lines of code, which is, I don't know, a big thing for me, because when I try to create programs with like SDL, like 3D, like Windows stuff, I always used it for like help to like, I don't know, to like ask questions and to make boilerplate code. So for example, I didn't know how to like create a window, like you need to first point to a variable, to like a window variable, and then you need to create it and all that stuff. I didn't know how to write that, and I used like a Claude to write that for me. But in this project, I have yet to use an AI, and I think it kind of shows, because I think git status, I don't know how to check it because I can't really use it, but I think this repository is more than a year old, and I only work on it on and off, and this is why I wanna record my progress on it, so maybe, I don't know, it helps me stay focused and stuff. Okay, I'm still recording. Okay, yeah, so basically this is what happens. We take the from index and the to index, so we can decide, we can infer that if we write this, we know where we are moving from and where we are moving to, which will help us decide if it is a legal move or not. Okay. What I also want to talk about, I wrote this function which basically takes a 64-bit unsigned integer and displays the binary representation of it. I think I've worked on this for like a week. I don't know, it's kind of difficult for me. And yeah, this is writing the board display string from the given fan string. Oh yeah, so this is how I make the board display. Okay, I'm gonna talk about this stuff later. And yeah, I have a binary printer function, 64, because we're using an unsigned 64-bit number. And I think in most of the code I wrote uint64t, as you should, but I saw a video from, I don't know the channel's name, but the very first video I saw from them was how they wrote like an arena allocator. I don't know what it means. Like I'm not a IT guy, but he did something like this where he was renaming these variables to like U8, U16, U32, and I think it looks cool. Basically that's it, so that's why I use them. Yes, okay. Yeah, and yeah, the binary printer function, basically I think the way it works is okay, so we don't move from the right, we move from the left. We take I to be like the 63rd bit. I wrote this like as an index, but we basically have 1. How can I explain it better? Oh my god. Okay, so basically, let's say we have a number like, I don't know, 15. The binary representation of 15 would be 16 minus 1, so this is 16, this is 8, 4, 2, 1, so 1, 2, 4, 8. Yeah, okay, so this is like, if this is like an 8-bit number, this is 1, 2, 4. Yeah, okay, so this is 15. Okay, so basically the program does something like this. We take 1, we move it to the left with a bit shift. 15? No, here I think 7 places. 1, 2, 3, 4, 5, 7. What? 1, 2, 3, 4, 5, 6. Sorry, 6, 7. We move it 7 places, so here we have it. The 1 is moved 7 places to the left, and then we compare these two bits, and I think I end it together. That would make sense. Yeah, if the index and the x where we are right now gives us back the index, which is 1, then we put a 1 there, and else we put an 8 there, and after every 8th bit we put an empty space there. So basically we compare these two values. If both of them are 1, then we print a 1, and if not, then we print a 0. So when the terminal is printing the values, this will be like a 0, and then I only move it 6 places to the left. I compare these two. I compare these two places. I get a 0. I move it again to the left by 5 now, I think. I compare them, I get back a 0. Okay, this will be like a 1. I get back a 0, and after that I'm gonna get to here. So this would be a 1, 0. Yeah, because we move it to the left like 3 or 4 pieces. I don't know. We compare it. We get a 1. Cool. Now it would be here, and we get a 1. So yeah, basically you just get the binary representation of a number. Yeah, you basically just get a binary representation of a number. And I've made this function because I think it helps to visualize what happens in the during the program. Yeah, I think it's cool. Like, you can clearly see that the black pawns all are in the same line, like this. You can see that the two rooks are on the side. And yeah. Okay, let's go back to the program. What do I have in store now? Oh yeah, I've also defined float and double as like a 32-bit floating. Is that right? Is a float a 32-bit? When did I write this? Is this correct? I don't know if this is correct, but who cares? Actually, who cares? Nobody's going to watch this. Oh yeah, when you input a move, I think, yeah, here it is. It's like a 4-byte character. So basically, if we write down E2 and E4, these are 4 separate bytes, or like 4 separate characters, which are 4 separate bytes. And I don't quite remember how the ASCII table looks, but every character has a value assigned to it in the ASCII table. You can look this up. E has something like 40 something, I think, and the numbers, I think letters start somewhere around like 64 or something, and numbers start a bit later, because if I go down here to the move deciphering part, oh, and you can see I'm a true larper because I use Vim, because it would mean that you can like write everything in the keyboard and you don't need to move your hands, but I still use the arrows, which is like a cardinal sin. But yeah, and where did I write the move? Yeah, the move from, okay. Why did I do that? Yeah, because I think the letters start at I think 96. I'm just going to quickly check it on my phone. ASCII table. So if you input a character, like, I don't know, A, inside the computer it's stored as an actual value. And I think the value for lowercase a is 61. No, it's 97. So it's 97. How did I do that? Okay, I think I remember, because we wanna decode the rank. Is that a rank or the file? I don't know English. Oh my god. Okay, so we need to decipher the column. Where do I have the board? Oh yeah, okay. We need to decipher which column is E. Okay, if we number it from here, this is the first column. I think this is how they do the second, third, fourth, fifth. This is the fifth column. I think the letter E is 101, and I discard 96 from it. So, do I have a calculator button on here or something? Oh my god, I have one. Nice, okay. So E was, I think, 101, and I discard. How much I discard? 96. Okay, I discard 96, and we get 5. Yes, and now we can see that this is 1, 2. Okay, we get back which column it is. Okay, and we do the same for the, I don't know, row. Let's just call it a row. So we need to figure out if I write down in the move section, so this is the 5th column, we need to figure out like, okay, the 2 is obviously the second row, but in the ASCII table the numbers start at the 0 is the 48th one, so we need to subtract. I can't speak English, oh my god. So we need to subtract 48 from it. So this is how we get, if we write down 2, which is in ASCII, like data is like 50, and we need to, minus 48 is 2. Okay, so now we know that this is the second row. Okay, cool. So we now know that this is the 5th row. This move, we are talking about the 5th row and the second column. No, the 5th column and the second row. So here, and we just take the end of this number. Or how do I do it? No, okay, so yeah, we basically see that this is the place that we're talking about. If we get the row and the column, we get the place. And here I do something like I think I am numbering the tiles from this to here. So this is, I think, the 0th one, the first one, second one, or like the first one, second one, third. I basically move from the rightmost bit in the bitboard representation. So I go from here, go in this way, and then I go up. So this would be like the very first tile which I calculate, and this will be the very last. So if I want to calculate which place this is, then this would be the, okay, if I get the 5th column, I would subtract from 9, from 9 I would distract the column, and then I will add. Okay, so this is basically just mathematics. I won't run everything. I won't run it down, but basically with this we get the number of the tile going from the rightmost down tile to the top left tile, I think. Yeah. Okay, so we have that, and after that, what happens? Yeah, we basically need to figure out which piece index that place is at, and I think I don't even need to show the code here, but I can show it. We basically I think make a 1, and then I just bit shift it left by that many times that I get from the from index calculation. So we have this number, and then I think I just do like a for loop, and I check every piece in the bitmap. I think I call this a bitmap. A fly is touching my leg, oh my god. I take every piece from the bitmap and I compare it, and when I find a match, I just basically say that, okay, this is piece index 0 because this was the first place that I found a match. And I think the check here is I take this and then an AND bitwise function and every piece in the bitmap. And I can stop at the very first I don't know, like found bit, like a piece, because if we would or all of them together, or like if we would add all of these numbers together, we would get a full piece, we would get a full 64-bit number, because it cannot be that in one place, like let's say here's a pawn and a knight on the same place, like that can't happen. So I can stop at the very first finding, or I don't know how you say it. So yeah, that's basically all I have yet. And right now I want to update the bitmap here, like let's say I make a move from e2 to e4, I would need to get the piece index, the 2 piece index. I need to figure out which tiles it. Okay, it's the empty tiles. I would need to update the empty tiles, I think, here. So this should be a 0. And from the white pawns, I need to get the from index and need to make this, this a 0. I can't highlight it. I need to make this a 0 because we moved a pawn from there. Okay, so yeah, basically I just need to, after I make a move, I need to update the bitboard. And I think that's all I should do first, and then I should think about the piece's capture range, if the move is actually legal. I think for now I should worry about only making making the moves possible, and also I should think about the game loop more, because right now I only do like a while loop. So let's see if I do it like a 5. I think I can input 5 moves before the program stops. So yeah, let's say e2, e4, e4, e5. Yeah, basically 4 or 5 moves before the program stops. So yeah, okay, so basically this is, I think I should write down a to-do list. So to-do, make moves, and after that check if the moves are legal. Well, okay, make moves, update the bitboard. I think this is kind of the same thing. And then I can think about all of the other things, but I think these are very important. Yeah, I need to update the bitboard accordingly. Okay, and I also wanted to talk about, I think, 2 different things, if I can find them in this board. I don't think I'll find it, but basically I wrote down 2 questions for myself. Yes, here it is. Okay. Okay, first, why am I writing it in C? I think it would have been more interesting if I started that with this, because it's more philosophical or something, but the way I studied how computers work and the way I learned how to write programs and stuff, I think it was very close to, I think, the assembly language. When I think about computers, they are basically, how do you say it? They are like an array of boxes, and into these boxes you can put numbers, and the CPU just basically manipulates these numbers depending on the program, or like instructions. So I don't know if you guys ever played the game Turing Complete, but there you need to make an actual computer, like a Turing Complete computer, and in that game basically you need to make these kinds of boxes called registers. How can I make it more pretty? Wait, I think I can now. Okay, so basically you need to make registers, and in these registers that you can put numbers. So let's say this could have like 120, I don't know, 125. The next register could have like, I don't know, the number 65, and so on. And then you can make you can do mathematical operations on them. So like you can add these numbers, you can subtract these numbers, you can push the number left and right, or on like the binary representation of them. So you can have this number like 0, 1, 0, 0, and let's say you can push it to the left by 1, so you would get 1, 0, 0, 0, and then you can push this number to the right, so you would get back 1, 0, 1, 0, 0, or or if you push it back one more time, you get this number. And then you can make logical operations on these numbers. So let's say you wanna make an OR operation, you would think about like, okay, 0 or 1 is 1, 1 or 0 is 1, 0 or 0 is 0, and so on. So basically the way I've learned like how a computer works is very close to this, like, I don't know, it's like a shoebox analogy. You have like lots of little boxes and you can manipulate the shoes or like the numbers inside of them. And I feel like this is just like talking out of my ass, but I feel like the C programming language is really close to how the computer actually works. And I don't know, I don't have lots of experience with programming, but I feel like when we, like in school, we used Python and stuff, or like C++, I think Python hides a lot of things that the computer does. Like it hides it from you, and yeah. And I don't know, I really don't have experience with this, so don't kill me in the comments, but I feel like C++ is just too complicated, or I don't feel like I need all of the functions or like the all of the pros that it has. I just don't need them. I feel like if I want to make something like a chess engine, in this case, I think the C programming language is more than enough. This is what I feel like. I think I will try to write down a script or like really flesh out my thoughts and research on why I think this, but I really feel like if I want to make something, like program something or anything, this language is enough for me. And yeah, and the other question was why a chess engine. I think I already answered this because it feels like a really fun challenge. I don't know, for me, these bitwise functions like swapping numbers left and right, comparing these huge numbers, and just basically feeling like, I don't know, you can see actually how the computer thinks. Like it's not actually playing chess like you, it's just comparing numbers. Like let's say I wanna move from, I don't know, e2 to e4, it would compare this number, like the 0, 0, 1, 0, 0, it would compare this number to, no, this, it would compare this number to all of these. It will figure out, okay, I want to move into the empty tiles. Okay, I need to update the empty tiles bitboard. So then I would do an, I don't know, like a subtraction, I think, or like an XOR or something. Okay, so I think it's really cool how you can actually see how the computer thinks. You can print out all of these numbers, you can see how it changes. If I can finally make the chess game up and running and actually think about how the AI works, how like a board position is evaluated with the evaluation function, I think these are really cool, and I feel like these are great learning opportunities for me to actually learn programming, because I really love mathematics. I'm interested in how computers work, and yeah, I think writing a chess program is like a really cool, I don't know, like a learning opportunity. Yeah, and basically that's it. I have no idea. I have no idea if I will actually upload this or not. Maybe. I think next time, if I am working on this, I will talk about how to update the display based on these numbers. I will try to think about them. And yeah, thank you for wasting 40 minutes of your life listening to a noobs and a larpers rambling. So yeah, thank you for watching.